the last little bit that we have in the nephron. Never thought we'd get here, huh? And here we are already. One of those things in which a journey, sometimes it feels like it's perhaps, a little taxing, but once you actually get here, then it's not so bad. And what you want to do, ladies and gentlemen, is keep reviewing, be able to answer the questions that I've been posing at you, be able to identify the patients that I've been giving you over and over again. And that way, the more number of times you go through this, the easier it becomes, and the more that you're able to integrate the material as needed. Where we are now is E is an epsilon, a collecting duct. We took a look at this picture earlier. Once again, quickly recap. We have the urine, the luminal side on the left. On the right is your blood, the interstitium. That green cell that you're seeing there is, in fact, the epithelial cell. One would be the principal because we're in the collecting duct. The other one would be, in fact, your intercalated. Next, what kind of receptors do we have here when dealing with two other major hormones? We have an aldosterone receptor, and we have an ADH receptor, known as V2 receptor. Aldosterone is what our topic here will be as we peruse through this lecture series. And aldosterone could potentially work on two sides of the cell. If it is on the side of the luminal membrane or apical, it then works on the ENaC. What does that mean to you again? Epithelial sodium channel. Whereas if it works on your sodium-potassium pump, that would be on the basolateral, all in the hopes of doing what, please? Reabsorption of sodium. What kind of effect does aldosterone have on hydrogen? It gets rid of it. So therefore, if you have excess, then you have an increase in pH. It gets rid of your potassium. What kind of effect would that have? Obviously, if there's too much aldosterone, you'd result in hypokalemia. Once again, if you had hypokalemia, then how is your patient going to present? Tired, fatigued because the muscles are not working properly, finding it difficult to reach threshold, and the heart obviously is an issue. Collecting tubule, when dealing with the principal cell, you're looking at sodium and potassium. If you're dealing with intercalated, it'd be hydrogen. Aldosterone results in increased sodium reabsorption. And then ADH here, as you see, you have two kidneys, thus it's V2 receptors. ADH, as we talked about earlier, is responsible for strictly inserting your aquaporin, and as long as, depending as to the osmolarity of the plasma, the example that I gave you earlier was severe sweating. You taste yourself and you taste salty, but you're losing more fluid, or you're not. So therefore, it's hypotonic loss of sodium. When you're losing that amount of fluid, then you know that your plasma osmolarity increases. Your osmoreceptors are very sensitive up by the hypothalamus, resulting in release of ADH, which then flows down your neurophycins and your infundibulum into the posterior pituitary, and out it comes. Are we clear? It also has effect on your V1 receptors, and vasopressin is what it's called.